What about Exo Dig? Well, here Baldwin's rules observes that some ring formations are favoured, but others are unfavoured, with the cutoff lying between the 5-membered ring and the 4-membered ring, with the 5-membered ring being favoured and the 4 unfavoured. We're going to start by looking at an example of a 5-membered ring process. To begin, we're going to deprotonate the alcohol with the base. The ensuing anion at oxygen 1 then attacks the alkyne at carbon 5, and we produce a new 5-membered ring. When we look at the reaction a little more closely, we can see that the alkyne bond is broken, going from a triple bond to a double bond. But only one of the atoms in the alkyne bond ends up as part of the new ring, so we see this broken bond as being external, thus exo. The first atom to be attacked in this ring formation is carbon 5. Now we know this is part of an alkyne, so it's diagonal, or dig. So what we have here is a cyclization that is 5-exo dig. The intermediate that's produced has an alkenyl anion. This then attacks the conjugate acid to provide the product, which is a cyclic enol ether. So that's the 5-membered ring process that is favoured. What about the 4-membered ring case? Are there any real-world examples where the unfavoured reaction actually happens? Well, there are, but they are quite rare, so we need to be careful. We're going to look at one example here. The first step in the process involves an iodo-lithium exchange. The anion that ends up on carbon 1 then attacks the alkyne at carbon 4. This produces a new 4-membered ring. Now, we can see the alkyne bond is broken, going from a triple bond to a double bond, but only one of the atoms of the alkyne bond ends up in the new 4-membered ring. So we regard the bond being broken as external, or exo. The first atom to be attacked in this ring formation is carbon 4, and we already said this is part of the alkyne, so it's diagonal or dig. So what we're looking at is 4-exo dig. Now we have an alkenyl anion. It's an intermediate, but the phenyl ring here is able to stabilize that anion and lower its energy. And this is key to understanding why this unfavored process in this specific case actually works. The anion then deprotonates an alcohol, and this results in the final product.